So here we are, chapter 3 in e-commerce. Now, one of the things you'll notice about this chapter is if you have already taken BA 131, there's a lot of overlap. A lot of the same material is covered in both the courses. So if you've already taken BA 131 and this sounds familiar, you should be able to just breeze through this chapter very quickly. There's a lot of technical stuff in this chapter, much more in depth than I think is really necessary for an overview and introduction to e-commerce, but that's what the author chose to put in. So I'm just going to highlight a few of the things of interest. I think the primary thing to know here is that if you ever need to know more about the details, it's there in chapter 3. You can refer back to it, but for most of what we're going to be talking about and dealing with out in the real world, this is a little overkill, I guess. So anyhow, let's get right in. So the first thing that is interesting is the evolution of the internet from when it started. And there's a supplemental video I've included in this week in the course content that is really, I find very interesting as it goes through the history of the internet. There's been a lot of misunderstanding and misstatements about the internet. The classic one is that Al Gore claimed he invented the internet. No, he didn't. He introduced a bill to provide funding for some of the internet, but he didn't invent it. He wasn't involved in the initial development of the internet at all. So really, we can see there was a major turning point, and like I say, the video that I've included in the supplemental video goes into more detail on this. But really, 1961 is when we see the coming together of several different systems to come up with the framework that is the internet that we know today. And the beauty of what they did starting back in 1961 is they established a system, a protocol, a method of communication that was not fixed. It was able to be dynamic and to change and adapt as the uses for the internet grew way beyond what anyone thought possible back in those days. A famous quote from the head of IBM back around that time, he said that on a global basis, he saw the need for one or two mainframe computer systems in the entire world, kind of thing. It was some really, in our terms of understanding today, a really silly quote. But no one back then envisioned what we would have today, because the computing power that was available back then, it was just not, it wasn't possible, it wasn't a thing that could happen. And so that's the really, I think, the beauty of what they did is they started with something that was only intended to communicate between the government and some key educational institutions. Very, very limited scope. And yet it was able to be adapted and modified to become what it is today. And we'll talk a little bit about some of the fundamental building blocks that make up the internet that has allowed this really amazing growth to happen. So as computers started to become more and more powerful and less expensive back in those the 70s, we started to see a migration, an implementation of computer systems that didn't take an entire building and require a massive amount of air conditioning. Really, with the advent of the integrated circuit, they were able to take these massive computers, like the one that was used to get us to a man on the moon, and make them smaller and smaller and more powerful, and started to see computers being rolled out throughout organizations. And of course, in 1980, IBM came out with their first PC. Apple had the Mac and the Apple II going before that. So we started to really see this proliferation of computing. It was not just limited to major institutions and the government, but it was those large institutions that funded during this time period. And again, it was still primarily a purchasing kind of project management communication. Email wasn't really in vogue yet. But then things changed. I remember when the first web browser was introduced, and all of a sudden people started seeing the possibility of how this could be used, and in particular in business. It was no longer in the realms of the educational institutions. They could see the potential uses of this really neat tool. And that's when the private companies really took over. And it was the private corporations with their resources and their budgets and their lack of bureaucracy. There's one thing you can say about the government is it moves at the speed of, of a turtle, that's, it's just amazing how long it takes the government to get anything done. But private companies can make things happen quickly. And so that's where we really saw things explode, is once we had the private industry invested into developing this and seeing where it would go. Unfortunately, in the evolution of the internet, no one had in their wildest dreams foresaw what it could potentially be. And so consequently, they did not build in a lot of safeguards on the internet. In fact, there were virtually no safeguards. It was assumed that people with good intentions were communicating with one another, and so why was there any need for security? Unfortunately, we're all too aware of the issues around cybersecurity, and that is the one thing I would say in the evolution of the internet where they missed the mark. They never envisioned that bad people would see this as a tool that they could use. And so consequently, when you don't design it from the beginning, adding it on has been very difficult to do. And we continue to have problems with data theft, stealing of people's funds, all kinds of things going on that are difficult to police, because the interconnectedness of the internet means the criminals, they're not in your neighborhood, they're on the other side of the world. And so it's very challenging. But anyhow, so let's move forward. So some key technology concepts, there's really three that stand out. The first one is packet switching. And the packet switching is really innovative, and has allowed the internet to grow rapidly without any problems, without systems going down, without having to do all these upgrades. And it's also made it very fault tolerant, so that you can lose power to New York and it doesn't affect anyone else's access to the internet. Now, obviously, if you're in New York, you don't have access to the internet, but the rest of the web stays up. So you can take out an entire part of the web of internet connections, and it doesn't impact the others. Now, as I mentioned, there's a video in the course content that deals with the development of the internet. There's also a very nice video on packet switching. It was actually developed by Spotify, and they explain, how it works. And I think they do a really good job. It's a simplistic presentation, but it gets the concept across, as how packet switching has enabled the internet to grow and to be extremely reliable. The key with any time you're talking with computers is you have to have an agreed upon way of communicating. And so when you hear the term TCP/IP, That's what they're talking about. It's the protocol on how you communicate data from one point to the other. So a way to think about this is if you think of the old snail mail, you get a piece of mail in your mailbox. Well, there's an agreed upon protocol that when you have a letter, that in the upper left corner will be the return address information, kind of centered on the envelope, maybe a little bit towards the bottom, will be the destination address, and it will be formatted with the name, a street name and number, a city, a state, and a zip code. That's an agreed upon protocol. So as long as you follow that protocol, you'll be able to get your communication, that letter, going from the sender's location to the recipients. That's all TCP/IP is. It's a protocol for how do you communicate on the web where this piece of digital data is supposed to go. It includes information, just like on your letter, the origination location and the destination location. And it's really important that you have the origination location because as is explained in that video from Spotify, what happens if the information doesn't arrive completely intact on the receiving end? Well, the receiving end knows which pieces are missing, and it can send a message back to the sender saying, please resend this part of the message. You don't have to tell it to send it again, start all over. It only needs the part that was damaged or missing from the communication. Another key concept of this, is the idea of client server. When you have this really applies to any computer system. You have a device that has the capability to do something. That's the server. It serves up solutions, answers, to what the client, the user, is asking. In the early days, we had, what were called dumb computer terminals. It was just a glorified typewriter with a screen that would show you what you were typing. All the computing power was done on the server. Then as the personal computers came out, we had, a workstation. So the client, it was a computer itself, so it could send requests to the mainframe that would serve up solutions, or it could do things on its own. And that's what we see predominantly today, although it's interesting because more and more we're moving back to this idea of client server, where you ask another device to do the work for you. You don't have to have this massive, powerful computer sitting at your desk. Instead, you're relying on the internet to provide that computing power. So we're kind of come full swing around from how things first evolved. So I will give you just a little bit of information on the packet switching, but again, I encourage you to watch that Spotify video. Basically, the concept is to take a larger digital message and to slice it up into smaller pieces. And the reason for doing that is that it's much easier to route small pieces through different channels than to try and send one big piece and have it arrive intact. And this goes what I was talking about earlier. If you slice it up into little small pieces, it's only the little pieces, if one or two of those somehow get messed up, that you have to request to resend. You don't have to ask for the entire file to be resent. And the interesting thing is, when you watch that video, you'll see how they illustrate that those little individual digital packets don't follow the same route from the source location to the destination location. Depending upon how congested the internet is in particular routes, some of the packets will go one way, then the routers determine that it would be actually faster and easier to go a different route. And so that information, that file that you're sending, may go through dozens of different paths, little bits of it going different ways. The way to think of this, it's like when you're on the freeway, if you see up ahead that, the freeway is really bottled up, but I know another route using side streets. And that's what a router does on the internet, is it's constantly monitoring how the traffic is on the internet, and it will reroute some of those individual packets to go a different route if it determines that that's better. So it's always looking for the optimal way of moving things. And that's part of what allows the internet to be so reliable and fault tolerant. And then, of course, when all the packets arrive at the destination location, you have to repackage those back into the file that was sent so that it's one piece of information, not a bunch of little slices. But in the process of repackaging that, that's when the receiving end can determine that, wait a minute, I'm missing packet 102 and 796. And so it can send a request back to the source location and say, please resend those two packets. Somehow they never made it. And as you heard me mention the term of routers, and you may have heard in setting up your home network or something that you have a Wi-Fi, router. It's just managing. It's the traffic control of determining where information goes. So at your home, you may have, 4, 8, 10 different devices, and that router determines, okay, this information, for example, my wife and I both have desktop computers. And so the router that we have in our house determines, okay, this piece of information goes to my computer, or it goes to my wife's computer, or it goes to the printer, the device, all the devices we have connected to our home network. The router that we have determines where the information needs to go. The key with packet switching to remember is it's really about optimization. You think about going to all the extra work to chop something up into a bunch of little pieces, and each individual packet that goes out has all the information of the source location and the destination location. So you think, boy, that's a lot of extra data you're putting on, but it actually turns out to be less expensive and wasteful because of this ability to get 99.5% of all the pieces there and only have to deal with the 0.5% that didn't make it for some reason. And the ability, as I said before, to get the fastest speed by going through the least congested route possible. So it's much less expensive and much more efficient than the older way of circuit switching. And the way to think of circuit switching, that was kind of the old telephone system. If you've seen the telephone operators where they grab a cable and they move it from this connection to this connection, basically that they were switching circuits. They were doing physical connections so that you had a direct connection from source to destination. Okay, so I mentioned earlier that TCP/IP is the agreed upon standards of how you communicate on the internet. But we'll go over just briefly some things that, like I said, the author goes into a lot of depth that you really don't need to know, but it's interesting sometimes. The TCP stands for the Transmission Control Protocol. That defines how it's like I said before with the letter. Where is the information located, and what's the format it's located in? And so you can see it deals with the assembly of the packets at the transmission by chopping them all up and correctly addressing, labeling each one, and then putting them all back together at the receiving end. IP stands for the Internet Protocol. And what this does is it provides the address that I talked before about, how you know where that piece is supposed to end up, who is the person that's supposed to get that. When we're talking about and you have to have both of those working together, the TCP IP layers, there's 4 major kind of designs on it. The network interface layer, that's what gets the packets out and receives them. The internet layer is how they get from point A to point B. And the transport layer is involved with other things that are going on the internet. You may have heard of other terms, UDP and QIC. Those are just other communication protocols that can exist in the digital world. And then the application layer that's used there. For the purpose of this class, you don't need to know anything about this. It's just kind of make you aware of. So when you hear the terms, you go, yeah, that's involved with the internet communications. Unless you're going to go deep into engineering or working on the web, this stuff it's kind of, it's interesting to hear about and talk about over coffee, but it's not that important. Something that is interesting, though, is when we talk about the internet addresses, and you'll hear that, someone talk about the IP address. The most common, once the internet started to take off, back in the 80s, early 90s, it's IPv4. So it's version 4. There obviously had been some previous implementations of the IP protocol. And again, that's the beauty, as I said before, of how the internet was put together, is that you can change the structure and the protocol without having to start all over. It's built to be able to be updated and revised. So IPv4 was implemented, and it consists of 32 parts, 32 bits, numbers, and it's 4 sets of numbers that you mark off by periods. And so, for example, that number is shown there. That's what an IP4 address looks like. Now, that was pretty good. That, when it was developed, provided for 3.7 billion addresses. But that was back when not everybody had a computer. Schools and businesses had computers. Most homeowners did not have a computer, and there certainly was no such thing as a smartphone. So 3.7 billion devices, that seemed like a pretty good number back then. But with the advent of the personal computer and cell phones and smart devices, video, doorbell videos, security systems, smart refrigerators, they realized very quickly that they were going to run out of addresses and everything would come to a halt. So they had to come up with a new version, and that's IPv6, and that was implemented a few years ago. They realized that just using numbers, so 0 to 9, really limits what you can do. And so they also expanded how big it is. So they made it 4 times as many pieces of digital information, but that goes exponentially, and you'll see in a minute. So as I mentioned, it's alphanumeric, not just numbers. And there's an example of an IPv6 address. You can see it's longer than the IP4, and it's got all, both numbers and letters in the address. By doing that, now instead of 3.7 billion addresses, it's 1 quadrillion addresses. Okay, so what the heck's a quadrillion? How can we put that in context? Well, it's approximately 120,000 per person on the globe. So every person in the world could have 120,000 devices. I think that's sufficient for a while. We're not going to run out of internet addresses anytime soon. Now that kind of leads us into domain names, because having an internet address, an IP address of, I'll back it up, of 201.61.186.227 is great. And you can type that number in just like that into your web browser, and it will take you to that. That's legitimate communication on the internet. But that's kind of a hard thing for us to remember, as humans, to remember numbers like that. It's much easier to remember names that make sense to us, like mypcc.edu. That's much easier to remember. So they came up with this idea of having domain names that would represent a unique number that is actually the physical address, the IP address of the device where you want to go to. So, it's just using language that we can easily remember. Now, the problem is, how do you make that translation? And that's through what's called the Uniform Resource Locator. You'll hear people talk about, what's the URL? That's, the mypcc.edu. That's the URL. It will get looked up, go to a table, a database that says, oh, what you really mean is this. So it's a process of having a lookup table, a database that converts that nice, easy name you can remember to the actual location where it's going. So here's an example. I've been talking about mypcc.edu. So that's its IP address. IP4, that's the address. Here's the IP6 address. Both of those will take you to the same place, the same location, the mypcc.edu. Now, so we'll see at kind of the end of this lecture, talk about who controls the internet. There is an organization that controls the names and the physical addresses that are associated with those. It's called ICANN. And when you want to have a domain name like mypcc.edu, you go to that organization. Actually, most people don't deal directly with ICANN. Instead, you go through someone that provides that service, like GoDaddy provides web services, and they can register your domain name for you. But this organization makes sure that you don't have two people registered for the same address, that same numeric IP address, and that the user-friendly names are unique so that there's no problem there. So they maintain that, and they maintain the databases around the world where the lookup tables are. Now, if you ever change, you have a website that's been hosted with a certain company and you change to another company hosting it, you put in a request saying, okay, mypcc.edu used to point to this location. I want it to point to this other location instead because I've changed the company where my website is hosted. It doesn't happen instantaneously. When you do that, you may have people still going to the old website for a day or two until all the different databases with the lookup tables get updated to reflect the new location for that. So it's just something to be aware of. I did have that happen to me when I was a webmaster um, for an organization, and we were doing exactly that. We changed who was hosting our website, and it did take a couple of days before everyone was going to the new site. Already talked a little bit about client server computing. Let's see, anything else we want to do? I think I've said all this. The servers, that's the workhouse. You store your files there. You have software applications, a lot of times printers there, and that may be how you get access to the internet, is through a server. And really, the internet, one way to look at the internet, it's an example of just a really large client server situation. You have all this computing power, and this has become very true now with cloud computing. You've got this massive server that has all this potential and capability to do things. And you, as a user, you're just a client sending a request out to it and say, hey, would you do this for me, please? Would you do a search on all the information that's out there and find me something that matches this? So it's, again, just a very large scale client server. Now it's interesting, and this is actually important for our e-commerce part of this. What has the smartphone and the tablets and laptops, what has that done in the impact in e-commerce? Well, first, now the understand is that, and this is true globally, but especially in the US and Western Europe, the primary way to access the internet now is through smartphones and tablets. In fact, they estimate 57% of global online shopping is done on mobile devices. But the interesting thing, and this is these numbers are from a study that was done by Citicorp Bank. 61% of consumers actually place their order on either a desktop or a laptop. They do the majority of the online shopping on mobile devices, but when it comes to actually placing the order, they're finishing it on a desktop or a laptop. And I think the primary reason there is the screen size. Depending on what you're ordering, what you're shopping for, a lot of people won't feel comfortable looking at it on a tiny screen. They want to wait till they get home and put it on a larger screen to look at before committing to buying that. So it's something to be aware of, that you can't ignore desktops and laptops, but likewise, you can't ignore tablets and phones either. You have to figure out a way of being effective with your e-commerce on all the platforms. Another thing that was interesting is that they found that 85% of the US mobile users prefer using a specific app rather than going to the company's website. And I think the reason that is so many companies were not very smart when mobile devices became popular, and they didn't do a good job of designing their website to be mobile friendly. And so the way they got around that in the early days was to create specific apps. Now, personally, I find it a pain in the neck to have to install, another app, another app and another app, and keep installing all these apps. I would rather just go to the website and have the website perform the same function. But for a lot of companies, when you go and you look at their website on a mobile device, you will find that it's difficult to use or it's too small to read. They have not optimized it for access on a mobile device. I really encourage, if you have any input into that in your organization or the company you're starting, whatever, to make sure that your corporate website is very mobile friendly. And there's some really nifty tools out there. It's not that difficult to do. When I had my portfolio resume it was hosted on GoDaddy, you could look at my website version of it and then go look at that same website version on a mobile device. And the mobile device looked great. It was easy to use. It worked just fine. But that's because GoDaddy had intentionally designed their products to automatically adjust and scale properly and do things if it was coming in through a mobile device as opposed to a computer. And yes, they do know when you go to a website, the browser knows what you're using. Are you using a laptop, desktop, cell phone, tablet? They know your screen size, what operating system you're using, a whole bunch of stuff of information is included in that web browsing so that they can optimize for it. 97% of the US mobile shopping uses a phone. That's even higher than on a global basis. But the interesting thing in the US, only 2% of mobile shopping is done using a tablet. For whatever reasons, tablets have just not been that popular. Personally, I prefer using a tablet to my mobile phone for shopping because of the screen size. But obviously, I'm in the minority. Okay, cloud computing. Mentioned before that this has really had an impact on the internet and how we use things, and this applies to e-commerce because it affects how we're going to process the data and that we have necessary to run our business. So things like storage and software, instead of being installed on our individual computers or maybe a larger computer that's at our workplace, instead we're taking that functionality and distributing it across the internet. And we don't necessarily know where it's occurring, and it's not necessarily important that we do know where, but we'll talk about some issues around that. But it's this idea that we can have these massive computers that you may have heard referred to as server farms that are doing all the work for us, and we're just sending the request saying, please do this for me, and then we get the answer back. One of the ways that is accomplished, and one of the things that's developed because of this, is the concept of software as a service. So in the early days of personal computers, you would buy a piece of software and install it on your individual computer. Depending on the license you had, maybe you could install it on 2 or 3 different computers. And that software was yours. You owned it. You could use it forever. Of course, the companies each year would come out with a newer version and encourage you, for only $25, you can upgrade to the latest version. But then they really started to move to a different model where the software is not installed on your computer anymore. Instead, the software is on the server that's located on the internet, and you access it. And so they aren't selling you software, they're selling you access to utilize and use and take advantage of software that is on their system. And that has changed the purchasing model from a one-time purchase to now an annual, or depending on the company and what you sign up for, it can be a monthly fee. More and more software is going that way. Even Microsoft Office is on an annual subscription basis now. You can still find, I'm trying to think what the last version was that Microsoft sold. that was basically a one-time fee for lifetime use. But the majority of companies now are treating it as a temporary service that you purchase. Now, there are both public and private clouds. So as a business, you could have your own private cloud system, servers and other things. It's expensive, but depending on how big you are, you could have your own version of that. I think the government probably has their own. But most of the when we're talking about cloud computing, we're talking about a public cloud. It's available on the internet if you have the right credentials. Of course, there's safety things put in place to prevent people from going where they shouldn't go. Now, there's some really great benefits with cloud computing. One of them that is really important is data redundancy. With cloud computing, your information is not held in any one particular location. It is spread across multiple locations so that if you have a tornado or an earthquake, some natural disaster, and it destroys, all the servers, you don't lose your data because there's a mirror image copy of that located in another part of the country, another part of the world. So cloud computing has been designed to have the data stored in multiple locations. So it would be a very unusual situation to actually lose all locations that have your data. So that's a really good thing because now I don't have to worry about it. Before this idea of cloud computing really took off, organizations were responsible to back up their own data on a periodic basis. And that was good as long as you remembered to do that. And what would typically happen is you'd run a backup of your data onto magnetic tape or to external hard drives. And then that would be then taken to an off-site location, put in a fire safe, for just in case something happened. And it did happen here. I live in Tualatin. The hardware store in Tualatin, it was over 10 years ago, maybe even be up to 15 years ago now. They had a fire started in the middle of the night and it burned the store to the ground. They hadn't been real diligent on their daily backups, but they had done them, every few days, and the data backup was taken to another location off-site. So fortunately, they were able to restore their data, and they only lost a couple, 3 days of information on that. But with cloud computing, we don't have to worry about that. One of the things that cloud computing does too is it really takes the cost out of infrastructure and IT support. If you're storing all your data on site on your own server, you have to have the support people there to run it. You have to have the backup systems, backup power supplies, all the things associated with that, not just the cost of the server, but there's a lot of cost to maintenance. And for example, when I worked at Leviton, the IT group was constantly telling us, you need to delete files off the server. We're running out of space. We don't want to have to buy another hard drive. We were constantly being told, to delete anything older than this, get it off the system. With cloud computing, you don't have to do that because the server farms, they're managing. If they need more space, they add more space. If you want to store more stuff up there, you just store it. You just have a data limit and you get charged for it, but it doesn't have that same infrastructure problem and challenges that we ran into when I was at Leviton. Consequently, too, the hardware that you have to purchase and maintain as an organization is a lot smaller. All you need are some relatively good computers. They don't have to be the latest high-end super processing, because you're using the computer to just send requests out to the cloud and say, please bring this back to me, give me this. So it doesn't take a really super powerful computer anymore. And software, it's a lot more cost effective to have a license that allows 50 people to access Adobe Acrobat than it is to buy 50 individual licenses of Adobe Acrobat and install them on all your computers, and then have to deal with, okay, they came up with a security patch. Has everyone updated their, and that's another advantage of the software as a service concept, is that you always know that you're using the latest version of the software, and that all the security updates have been installed because you're working off of their implementation. You don't have to worry about all the individual units in your organization. But like anything in life, it's not perfect. There are drawbacks. One is that the responsibility for the storage and the control, providing the security of your data, it's no longer in your organization. It's outside of your company. You're relying on someone else to take care of your data and to make sure that it doesn't get destroyed and that it doesn't get given to people that should not have access to it. That's a huge responsibility that you're giving up any involvement with. So it's really important with cloud computing that you understand the company you're dealing with, because you are trusting them to to be responsible for a key part of your business. And if they don't live up to that responsibility, it could cripple your company. And so the primary one, like I was talking about there, is the security risk. Now it's kind of a yes and no, because these cloud computing companies, they're large enough that they can employ a very large staff of people who are monitoring and looking for security problems, constantly upgrading their procedures and the firewalls and the antivirus software. And they have all kinds of software that analyzes, that looks for suspicious activity, something that doesn't make sense. You get a bunch of requests coming from an area of the world that this company has no offices in, and so why would someone be trying to access data from that? So they have the ability to staff much greater than you could at your company. You can't afford to employ that many people focused just on security. So it's kind of a yes and no. One is that you're relying, you're abrogating, you're transferring that security responsibility to someone else. But also, if you pick the right company, they have the ability to have much more investment in their security staff than you could as a business. Now, there can be sometimes with cloud computing where you can get some slowdown in the data retrieval just because you're going out through the web. And so if you have a bunch of web traffic going on, it can make it harder to get the information back and forth and get some slowdown. But that really isn't much of an issue most of the time, because of the routers and the packet switching, the way that's being handled. The system is very good at minimizing any latency that might be due to heavy traffic. But something that you don't hear people talking about, this cloud computing is great, but server farms take a lot of electricity. And this is being really compounded with the excitement and enthusiasm that a bunch of people have about AI. It takes a lot of server power and a lot of power, period, electrical power, to provide all of that. Our power grid was maxed out before. We're really looking at some serious problems with the power grid now. If something isn't done very quickly, we're going to see rolling brownouts in major cities around the country on a routine basis. It'll be something that everybody's just aware of because we don't have the capacity to provide more power to the grid. It's not a matter of just build a power plant. One, it takes years to build a power plant, but the wires, the transmission lines that we get the power around, everything is pretty much maxed out. And that was one of the shortcomings of this push for electric vehicles, is that no one really looked at, but can the power grid handle, if we converted as many vehicles as like California wants to do to electric vehicles, how are we going to charge them? The power grid is maxed out. You can't just be adding more load and expect that somehow it's magically going to be able to get electricity to it. So that's a real issue. And like I say, unfortunately, I just don't hear any politicians and others talking about this and looking at it. And it's something that needed to be talked about 10 years ago, because it does take a long time to make any changes. But the last thing I wanted to mention about Cloud Company 2 is, if you choose to utilize cloud services, what happens if the company that you're working with goes out of business? Businesses do fail. What happens if they had a big controversy, fiasco, the CEO embezzled a bunch of funds or whatever, and so they go out of business? Will you still have the ability to access your data? Will you be able to transfer that to someone else? How does that work? So there's, like most things in life, I would say this is just one. I use cloud. That's how I back up my personal computers. I back them up to the cloud. But think about the company you're dealing with, and just understand the limitations. I already talked how the internet's been able to grow just phenomenally because of the way it was built. And as I said, packet switching is just wonderful. Some other terms you might hear, the wireless local area network. And you'll hear talked about 802.11, or Wi-Fi 4, 5, 6, or 2.4. Those are different IEEE engineering standards for the communication protocol. So why is that important? When everything started taking off with the internet, we were using Wi-Fi 2.4. 2.4 gigahertz is what that refers to. And a lot of devices were designed around that, but then they realized, boy, we really want to get more data. For people to be able to stream video on their phones, we need to get more data, so it has to be operating in a different frequency, a higher frequency, to get a higher bandwidth. So then came out Wi-Fi 5, and then now even Wi-Fi 6. The problem is, a lot of devices were designed around utilizing that 2.4 gigahertz protocol. And they just don't work right if they connect to a 5 or a Wi-Fi 6. And so when you set up your video doorbell or your smart appliance or whatever, you'll have to look at it, and they will tell you if they're compatible with both Wi-Fi 5 or if they're just 2.4. And if they're only 2.4, you may have to run through some, jump through some hoops to get them to connect properly with your network. What I ultimately had to do for my devices, I had to create a second network, Wi-Fi network at my house that is only 2.4. And so I have my devices that require it connect to that, and I let my laptop and my cell phones connect to the main Wi-Fi that will switch between 2.4, 5, and 6, depending on what the best signal is. Wireless access points, I'm sure you all know about those. There's been talk about metropolitan area networks. Portland tried, golly, I think it was over 10 years ago. They awarded a contract to a company to provide wireless internet access to the entire city of Portland. But in typical government fashion, they chose to award the contract to a company who had never installed, designed a citywide wireless system. So no surprise, they didn't get it to work at all. They never got one single block of wireless access to work. But there is a protocol and a standard to use for wireless citywide. I'm trying to remember now. There was one of the carriers had talked about possibly coming into Portland and providing, implementing a metropolitan area-wide wireless. I think what's happening now is that more it's switching to going to take advantage of the satellite wireless, and getting the costs down on that is a better solution for citywide technology. The other thing, you hear about Bluetooth, and Bluetooth is an electronic radio frequency, wireless device, but it's different. The reason that's different, like my mouse here has no wires on it, and it communicates via Bluetooth. Bluetooth was designed for mice and keyboards and printers that have very low data requirements. There's not a lot of data that goes back and forth. It's a slow device. And so it doesn't have to have this high bandwidth performance. And so Bluetooth was really designed to implement that, to provide a very low cost solution to getting rid of the wires. But consequently, they didn't try to make it go very far. So typically you're only a 30-foot radius or a 30-foot distance for it to work. You might be able to get 40 feet if you don't have any walls in the way and so forth. But it's a very much meant to be that the device is right next to it. When you put your earbuds in and they connect to your cell phone, that's Bluetooth. And so very short distance, and audio that you're transmitting to your earbuds is a very low bandwidth requirement in terms of the amount of data that has to go through. The Internet of Things. I've already talked a little bit about this. Objects that are connected to the internet. And this has really been enabled because the price, the cost of putting that the circuitry in to be able to connect to a Wi-Fi has become so low that manufacturers can include it in the other circuitry they're designing in their product anyway, to allow it to be accessed and controlled remotely, from your cell phone with an app. For example, I've got, for watering in my yard, I have a number of watering control devices hooked up to my faucets around the house. So I've actually got a total of 10 of them hooked up. And each one of those go, and they go to a particular drip watering system. And I can control those from my smartphone. I can program them in when they come on, how long they run for, and all that. And that's because of these low-cost sensors. They were able to put that capability into a water faucet timer that Well, I think what I paid for each one of those, they're like $35, $40, so it's that low cost connection circuitry that really allowed that. The other thing that's allowed the Internet of Things really to take off is the price of the cloud storage. Analytics software, the IPv6 was essential because as Internet of Things started to explode, we were very quickly running out of IP addresses. Well, you can't have an Internet of Things if you don't have any addresses to give the device, because you can't communicate unless you have to have a unique address to be able to talk to that device. There are some issues with interoperability and standards, but probably the biggest issue with the Internet of Things is security. The old adage is true: a chain is only as strong as its weakest link. If I've got, let's say, 30 devices at my house connected to my home network, if one of those devices was designed by a company that wasn't really great at security, and a cyber criminal knows that and they can hack into that device, they get access to my entire network because they're on the network then. And there have been cases. There was a hospital. Their entire hospital system was hijacked. It was encrypted and then ransomed to the hospital. They wouldn't unencrypt the hospital records unless they paid him a large amount of money. And the way they got into the hospital system was through, if you've seen hanging on the drip pole, someone where they're getting like saline solution with a drip. It was one of those devices, and the company that had made it didn't do a very good job of building in security, and the cyber criminals had recognized it, so they were able to sit outside the hospital, access that device through, they had a strong transmitter, and get into the hospital that way. So there are real security issues with the Internet of Things. The way I like to think of it, and what I tell my students, is buying cheap devices, less expensive devices. If they connect to your internet, that's not a good idea. You want to be staying with the brand names, and someone that has a reputation of designing in that security, because there's no way for you to verify it. You're trusting that that company that made your video doorbell is doing a good job of designing in the security protections on their system. So a cheap knockoff is not a good idea. And especially something that, since most of them are manufactured and designed in China, there might be some back doors intentionally built into that device to allow criminals and others to gain access. So buying cheap is a bad idea when you're talking about the Internet of Things. So I mentioned earlier before, the first one, the top there, ICANN, handles the managing of that database. That's the lookup table from the user-friendly name to the actual numeric IP address. There's a number of other groups listed here that are involved in certain aspects of it. But the key is there is really no organization, no government that governs the internet. That's both a good and a bad thing. We want free flow of information. We don't want anyone regulating the internet. As soon as that happens, we know that leads to censorship. Just look at China and the Middle East, other areas around the world where the government in those countries controls the internet, and they are able to filter out stuff that is not consistent with their views and opinions. It would be nice if there was some way to better regulate it, to keep cyber criminals off the internet, and to also to deal with things like cyberbullying. But the problem is, as soon as you start doing that, it's a slippery slope into censorship. And so there are working groups that to get together, like the Internet Society and others that talk about the next generation, where things go from here. I mean, that's how the IP6 was developed to replace the IP4. It was a worldwide consortium of engineers getting together and talking about how can we do this. But there is no one who really governs and controls the internet per se. Okay, that's it for chapter 3. Again, as I mentioned, there's a lot more detail in the chapter that you read, and a lot more than what you need to know. So feel free to do some speed reading on that.